Hello, algebra classes. Okay, we're going to start looking at the last lesson in our chapter 9 that will conclude our study of quadratic equations. We're actually going to do some recalling about our linear equations and our exponential equations. We're going to be doing some comparing of these linear, quadratic, and exponential equations. So we're going to start with example 1, where we're given some ordered pairs, and we're going to graph the ordered pairs that we're given to determine if the relationship is linear, quadratic, or exponential. The method we're going to use is taking a look at the graph. We know the shapes of graphs that are linear, quadratic, and exponential, so once we've plotted the points, we'll look to see what shape we see on our graph, and we'll decide then whether or not that is modeling an exponential, a quadratic, or a linear relationship. So on letter A, we can see when we plot those points that we have the classic exponential curve. In this case, on the left, it's very low, hovering right above the x-axis, and as it moves to the right, it zooms up very, very quickly. So based on the graph that we see on example 1A, we claim this is an exponential relationship. So on part B, we're graphing the ordered pairs that you see here, and when we connect those points, we see a very straight line. So we conclude this is a linear relationship. The graph is a line. Letter C. These ordered pairs, when we graph them, create a parabola. And we know that anytime we see a parabola, that is a quadratic relationship. So again, for this part of the lesson, we were using the shape of the graph to determine whether or not we had an exponential, a quadratic, or a linear relationship. Now, the next part is we're going to take a look on page 626. This is at the top of the page. It's the stuff that's above example 2. And we're going to use the idea of either differences or ratios to show that a relationship is linear, quadratic, or exponential. This time we're not graphing to figure that out. We're going to look at the special relationships that occur when we have linear, quadratic, or exponential relationships. So I'm going to give you the equation. We're going to recognize this as a linear equation because we see just y and x with no exponents higher than 1. Nonetheless, given this equation that we know is going to be linear, we're actually not going to use that to determine that this is a linear relationship. Instead, we're going to take a look at the table of values. These are points that we could plug in for x, and that would give us the y values that you see down here in the bottom row. We're always going to be looking at tables values for x is increasing by 1, and then we're going to look and see what's happening in the bottom row to the y values. So in this case, we're noticing that each y value is increased by 3. 2 plus 3 is 5, 5 plus 3 is 8, 8 plus 3 is 11. And so we are going to conclude this is linear because the first differences are constant. Now when I say differences, that makes us think about subtracting. And even though I'm showing addition here, 2 plus 3 is 5, the idea of differences comes from take the number on the right and subtract the number on the left, and that gives you 3. 8 minus 5 is 3, 11 minus 8 is 3, and that's where we get the idea of differences. So if our bottom row, or y values, have a constant first difference, that is, this number comes out the same, whether it's adding or subtracting a particular number, then we will conclude that is a linear relationship. What about a quadratic relationship? Well, a quadratic relationship will have what we call constant second differences. So here is the equation that I'm plugging into. We recognize this as a quadratic relationship because we see y and we see x squared, but we're not going to use the equation to conclude this is a quadratic relationship. Instead, we're going to look at the table of values, where I've again chosen x to be increasing by 1, and when the x is increasing by 1, we're going to see what's happening in the bottom row. Well, at first, it doesn't look like anything in particular is happening. 5 minus 3 is 2, 2 minus 1 is 1, 1 plus 1 is 2, 2 plus 3 is 5. We're not getting the same difference each time here. We're getting different numbers. But look what happens when we take these first differences and we say, well, what about the second difference? Negative 3 plus 2 is negative 1, negative 1 plus 2 is 1, 1 plus 2 is 3. Oh, and our second differences, they all come out the same. So a quadratic relationship will have this situation crop up where our y values exhibit second differences. The first time you do your subtracting, 2 minus 5 is negative 3, 1 minus 2 is negative 1, 2 minus 1 is 1, 5 minus 2 is 3. Those will be different numbers, but then when we find our second differences, they will be constant. They'll be the same. So because we have second differences of 2, we will conclude this is a quadratic relationship. What about exponential relationships? Well, again, I've given you the equation that I'm plugging into to create the table of values, but we're not going to use the fact that we see x in the exponent to conclude that this is an exponential relationship. Instead, again, we're going to look at the table of values. And again, we're setting it up so x is increasing by 1, and when x is increasing by 1, we're going to see what's happening here in the bottom row. Well, this time we can't add or subtract any number in first differences, second differences, third differences. That will never come out the same. But here we're going to notice that we can multiply each y value by 2, and it will create the y value to the right. 1/4 times 2 is 1/2. 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. So we have what's called a constant ratio of 2. Now, ratio reminds us of something that looks like a fraction, a top number over a bottom number. Where does that come from? Well, actually, it's kind of like when we were looking at our linear and quadratic relationships. We're going to take the number on the right, in this case 4, and divide it by the number on the left. 4 divided by 2 is 2. There's our constant ratio. 2 divided by 1 is 2. 1 divided by 1/2 is 2. 1/2 divided by 1/4 is 2. So we can arrive at our differences or our ratios a couple of different ways. One is going to the right, asking what do we need to multiply by in this case to move from 1/4 to 1/2 and from 1/2 to 1. Or we can take the number on the right, divide it by the number on the left, and that also will give us that same constant ratio. So this is an exponential relationship because we have a constant ratio of successive y terms, and that ratio is 2. All right, that concludes our guided practice problems for this lesson. It's time for you to move on into the homework and practice part of this lesson, and we'll see you next time.